All right, moving on to page 3, starting with number 25. It says identify the vertex and the y-intercept of the graph of the function. Well, the vertex is going to be at the point 3, 2. Move over 3 to the right and 2 units up. That's the vertex. Then the y-intercept, people struggle with that, but here's what it means. The y-intercept could be here, or here, or here, or here. It's 0, 1, 0, 2, 0, 3, 0, negative 1, but it's 0 something. That means I've got to find the y-intercept, I'm always going to plug in a 0 for x. So if I plug in a 0 for x, this is going to be 0 minus 3, which is negative 3. Negative 3 squared is 9. And I'm going to make it negative 9, and negative 9 plus 2 is 7. No, negative 9 plus 2 is negative 7. So the y-intercept is at negative 7. Or we could say 0, negative 7. And this is the y-intercept. That's number 25. 26. It's a little bit more difficult than the one on page 2 because this has an x both inside the absolute value and outside the absolute value. But I'm going to start it the same way. I'm going to write it in two different equations. One equation is going to be 2x plus 1 really does equal 6x plus 7. The other one's going to be that 2x plus 1 equals the negative of that, which is negative 6x minus 7. So I'm going to solve the first one first. I'm going to subtract 2x from both sides. This is going to give me 4x. If I subtract 7, that's going to give me negative 6. And if I divide by 4, x is going to be negative 6 over 4, which is negative 3 over 2. And if I solve for the next one, I'm going to add the 6x, which is going to give me 8x on the left-hand side of the equation. If I subtract 1, that's going to give me negative 8 on the right-hand side of the equation. And if I divide by 8, x equals negative 1. So it looks like they both work at first. But if I were to try to plug this one in, I'm just going to plug it into the right-hand side of the equation. If I were to take 6 times negative 3 halves, that's negative 9. And negative 9 plus 7 is negative 2. Well, it's impossible to have an absolute value equal to a negative number. This is going to be an extraneous solution. Now, the x equals negative 1, that will work because 6 times negative 1 is negative 6, and negative 6 plus 7 is 1. So I'll have 1 on the right. And then if I plug negative 1 in over here, 2 times negative 1 is negative 2, and negative 2 plus 1 is negative 1, but the absolute value of that is 1. So I get 1 equals 1. This equation, or this solution works, but my other one is extraneous. Let's take a look at 27. So 27, I'm going to start by cross multiplying. I'm going to take x plus 2 times x plus 4. That's going to be x squared plus 2x plus 4x plus 8. That's going to equal my other cross product, which is 3x times x minus 3. Well, that's 3x squared minus 9x. So if I combine like terms, I'm going to try to get everything over on the right-hand side of the equation. So this is going to be 0 equals 3x squared minus x squared is 2x squared. 2x plus 4x is 6x. And if I subtract 6x, negative 9x minus 6x is negative 15x. And I'm going to subtract the 8. Well, I don't know if I can factor this, but I'm going to try here. I'm going to try a 2x times an x. That gives me 2x squared. And then things that give me 8, let's see, 4 and 2. I don't think that's going to work. 8 and 1, I don't think that's going to give me a 15. Doesn't look like I'm going to be able to get something that factors here. Which means I'm wondering if I did something wrong here. Let me just check this. This is going to be x squared plus 2x plus 4x plus 8. This is going to be 3x squared minus 9x. Yeah. And then, let's see, this is 2x squared. If I subtract the x squared, and then 2 plus 4 is 6, so 9 minus the 6 is negative 15. Negative 9 minus the 6 is negative 15. I subtract the 8. Yeah, it looks like I did that right. So if I can't factor it, well then what I'm going to have to do is either use the quadratic formula or completing the square. And I'm going to use the quadratic formula here. This is going to be negative b, which is 15, plus or minus the square root. I'm going to check. Something tells me that I'm just missing something here, but I want to make sure that I'm on the right track here. Number 27. Looks like I should be able to factor it. Oh, yes, I could have factored it, because 8 times 1 gives me 8. So if I put the 8 here and the 1 here, and I make this negative and this one positive, I can factor that. Because my outside term is going to be negative 16x, my inside term is 1x. And so negative 16x plus 1x is negative 15x. All right, good. So then I'm going to let this be 0, which means I'm going to have to subtract 1 and divide by 2. That's one solution. And then here I'm going to just add 8, and that's my other solution. So my two solutions are negative 1/2 and 8. Another thing that I could have done is graph both of these on my graphing calculator and see where they intersect. And that would be another way of doing it. Let's take a look at 28. This expression models the height of the object t seconds after it has been dropped from a height of 22,000 feet. Find the height of the object after falling 4.6 seconds. Well, I'm going to use my calculator for this one. So I'm just going to plug in 4.6 seconds in for t. It's going to be, I'm going to have negative 16 and then times t squared, which is 4.6 squared. And then I'm going to add 2,000. And that gives me 1,661.44 feet. And that's how high it would be. Let's move on. Take a look at number 29. We're going to factor this completely. So see if I can do a better job of factoring here. This is going to be, let's try 3n times 2n, because that gives me 6n squared. And then something that multiplies together to give me 15 is 5 times 3. So if I put the 5 here and the 3 here, and I make this one positive and this one negative, this is going to be 10n minus 3n, which is 1n. And I can't factor that anymore. It's just going to be 3n plus 5 times 2n minus 3. Number 30. State the number of complex roots. Well, it's a 6-degree polynomial, so there are 6 complex roots. Well, what that means is there are a total of 6 solutions. Some are going to be imaginary, and some are going to be real. But the imaginary ones always come in pairs. So I could have 0 imaginary ones, or 2, or 4, or 6. All 6 could be imaginary, which means that if 0 of them are imaginary, 6 would be real. 2 are imaginary, 4 would be real, or 2, or 0 if there are 6 imaginary ones. So that's number 30. Number 31, determine whether the function is linear or quadratic and identify the quadratic, linear, and constant terms. So what I'm going to have to do here is to actually FOIL this. I'm going to have x times 6x is 6x squared. X times negative 6 is negative 6x. 1 times 6x is positive 6x. And 1 times negative 6 is negative 6 minus 6x squared. So let's see. 6x squared minus 6x squared cancel each other out. Negative 6x plus 6x, they cancel each other out. And y is just negative 6. So there is no quadratic term, there is no linear term, there's just a constant term, which is negative 6. Let's move on up here to number 32. For number 32, we're going to write an equation for the translation. So here's the original parent function here. It's just y equals the absolute value of x, but it looks like I slid it down 1, 2, 3, 4 units. So this is going to be y equals the absolute value of x minus 4. Number 33, a manufacturer determines that the number of widgets it can sell is given by this formula. So D is the number of widgets it can sell, and then the price is what P is. It says at what price would the manufacturer sell the maximum number of widgets? And so we're going to need to grab our calculator for this one. I'm going to type this into my graphing calculator. This is negative 4x squared plus 168x, and then minus 345. So if I graph that right now, it's going to tell me, I think I'm going to have to change my window here. Yeah, because it goes up so high, it looks like. So I don't know what I'm going to change my x values to, but I think I'm going to have to go higher than 10. So let's just try, I don't know, 50. And I'm going to count by 10s here. And then I'm going to make the x values go from negative 10. Let's just try 500 and count by 100 and see what happens. So it looks like I'm going up. Do I show the value coming down? I do. But I didn't go high enough because I want to know what is the maximum. It's not on my screen yet. 500 wasn't enough, so what I'm going to have to do is maybe if I go to, I don't know, 2,000, and I'm going to still count by hundreds. There we go. That's going to work. And so if I make the price too small, I'm not going to make very much money. If I set the price higher, I'm going to make more money until people decide that, man, that's too high. I'm not going to spend that money on that item, whatever a widget happens to be. So I want to find the maximum profit, which is the maximum there. I'm going to go to um, I'm going to go to the maximum value, move to the left, move to the right, and my maximum is going to happen when x is equal to $21. My maximum is going to be 1,419. Now, I kind of cheated there by using my calculator, um, but you could have also have done this by doing negative b over 2a, because that would have given you the vertex as well. So that's 33. Number 34. 34 is a special equation where this is the difference of two cubes. So there's going to be a small factor and there's going to be a big factor. The small factor is simply going to be 3x minus 5, because the cube root of 27 is 3 and the cube root of 125 is 5. This sign always matches this one. Well, then to get the big factor, I'm going to take the first term and square it. Well, that's 9x squared. To get the last factor, I'm going to take the 5 and square it. That's 25. It's always going to be positive. And then the middle term is going to be 3x times 5, which is 15x. And if this is a negative sign, this is going to be a positive sign. I haven't solved anything yet, but I have factored it. So 1 0, is going to be when this is equal to 0. And I would add 5 and divide by 3. That one was pretty easy to solve. This one is a little bit more complicated. In order for this to be equal to 0, I could try to factor it, but I don't think it's factorable. So I'm going to use the quadratic formula here. This is going to be negative 15, that's negative b, plus or minus the square root of 15 squared. Well, 15 squared, I'm kind of have to cheat on my calculator here. I think it's 225, but to make sure, 15 times 15, yeah, 225. So this is 225 minus 4 times a is 9 times c, which is 25, all over 2 times a. Well, that's 2 times 9, which is 18. Well, inside the radical sign, it's going to be 225 minus 4 times 25 is 100, times 9 is 900. Well, that's going to be the square root of negative, let's see, that's 675, I think. And so 25 I know goes into 675. If I take 675 divided by 25, I get 27. So this is going to be the square root of 25 times the square root of 27, which is the square root of 9, times the square root of 3, times negative 1. Well, the square root of 25 is 5, and the square root of 9 is 3. That's 5 times 3, which is 15. This is going to be negative 15, plus or minus 15. The square root of negative 1 is I, and I still have that radical 3 there, all over 18. Now, that's the correct answer, but it's not simplified, because I can divide all of these by 3. And if I do that, it's going to be negative 5 plus or minus 5i radical 3 all over 6. And that's what my other x values will be. Let's take a look at 35. When spheres are us ships bags of golf balls, the number of balls in each bag must be within 4 balls of 250. Write a compound inequality. Let's do that first. The compound inequality is going to look something like this. The number of golf balls, I'm going to call that x, has to be less than or equal to 254, but greater than or equal to 246. Because that is 4 golf balls away from 250 in either direction. So that's my compound inequality. Now I could also write it like this, and maybe this is the form that they're looking for on your test. I would have the absolute value of x minus 250 has to be less than or equal to 4. And this is the variance. This is always the middle number, and it's going to be less than or equal to, because I want it to be closer than 4. The reason why this is the same as this is because if I were to rewrite this equation, I would have x minus 250 is less than or equal to 4 and greater than or equal to negative 4. To solve this equation for x, I would add 250 to both sides. Negative 4 plus 250 is 246. And 4 plus 250 is 254. And so I get the same thing. So you should be able to write it as a compound inequality, which is this one, or as an absolute value inequality. Take a look at number 36. A rectangle is 5 times as long as it is wide. So here's how wide it is. I'll call that x. 5 times as long is going to be 5x. And then the perimeter is 80. Find the dimensions of the rectangle. So it's going to be, this is x, this is 5x. So 5x plus 5x plus x, that's 12x equals 80. And so I'm going to take 80 divided by 12, which is 6 2/3. Let me see if I read that right. It's 5 times as long as it is wide. Yeah. The perimeter is 80. Find the dimensions of the rectangle. Round to the nearest tenth. So round it to the nearest tenth, so it would be 6.6, actually 6.7 by 5 times that. If I multiply that times 5, it's going to be 33.3 repeating. So 33.3. And that would be the dimensions of the rectangle. Guys, that is page 3.